Photoelectronics Lab, University of Madras. Just going to give you about how to install Fityk software and to plot various data in that software. Here we are going to mainly concentrate about how to fit the XPS data and to make sure that you get a proper fit in the software. Firstly, just open any browser. Here we are going to use Google Chrome and just type Fityk software download, and that is the option here. If you press this, the software will be downloaded, and you have to press according to any types. For if you're having a Windows, you can use Windows. For Mac OS and Linux, each and every versions are there, you can press there. So since I already downloaded it, I will show you how to download it further. Yeah, since my Fityk software is here, so I'm just going to open the Fityk software. Yeah, and this is the Fityk software. It has various amount of functions. Here we can see this is the session. Session consists of a script, how to edit the script, new script or the recent script. This script indicates the data that you're going to upload in this website or in this software. And the data is nothing but the data file that you're having in your my files could be copied and to be pasted here, so we can be able to fit the various amount of data. And functions is nothing but the types of functions that you are indeed going to be used for fitting. For here I am using Gaussian. There are many types of functions present here, so you can use the functions that is required according to your requirement. And here it is the fit. It's starting the method. All these methods are little similarly the same. It will going to lend you the same amount of results, but you can use whatever the method you want. This is tools is nothing but the types of things, and this is the mode, and this is the help option. So this is how the Fityk website will be. So primarily, first here we are going to concentrate about XPS data, and I'm going to choose here is ytterbium oxide data. So primarily what you have to do is that first take your ytterbium oxide data. Yes, here I'm having my ytterbium oxide data of the XPS. So I'm just clicking on it, and you will have a various amount of data like this. So this is the actual representation of your ytterbium oxide data for an XPS. So we are going to take this data, copy these data and paste it in Origin software, and we are going to fit it. So we are going to copy this one. We are going to copy all these data, and we have to going to do Control C option and go and check into the, and your data will be present like this. So this is the rough fitting of your data. So what you have to do is that you have to decorate your borders, and you have to make sure you have to point the edges or the points which is this one and that thing. And finally what you will get an image like this one. This is the image of the data that is being fitted after the Origin software. So here you will have the peaks, the three peaks, the YB4D, the C1 carbon peak and the oxygen peak. This is the fitting after the Origin software. So you will get it like this. This is the binding energy and on the x-axis and the counts on the y-axis. This is how you will get your data, basic data for the XPS. So next what you are going to do is that there are three types, as I said, the carbon, the oxygen and the ytterbium. So you have to collect the three data like this, and you have to go and plot it in the Origin software, and you will get the images like this one. So you have to peak fit each and everything and just transfer this data into the Fityk software. Now here there are different, and you see on the bottom, this is the XPS survey. XPS survey is nothing but the actual representation of the ytterbium oxide sample in the X-ray. So these are the peaks, that is the YB4D, the oxygen, and here will be the carbon peaks. Okay, and here this is the peak table, the table at which it's according to the XPS data given. So we need this one, the YB4D scan. This is the ytterbium scan. So what we will do is that we will just copy the data and be posting it into the Origin software, and we'll be fitting all the points, and then taking that data we'll be using it in the Fityk software, and we'll be plotting the data. This is for the ytterbium, and this is the readings taken for the oxygen unit, and this is the scan for the oxygen, and finally the carbon scan. This is the image, these are the readings the readings of the binding energy and the counts, and this is the scan for the carbon. So I will be teaching you how to copy these images and post it into the origin software to pick with the data, and from there how to capture the data from that and put it in the Fityk software and get your fitting. So primarily I told you about the total ytterbium oxide scan. So this is the XPS survey of the ytterbium oxide scan, and as I have been fitted it here, and I have shown you that in the image it will be like this. So now we are going to take another image, that is nothing but we are going to take for the ytterbium oxide scanner. So what will you do? Primarily we will just copy the data. We will copy the data and copying the data, and we are going to the origin software. Take another workbook, and in this workbook we are going to paste it. Yes, we got the data. So what we are going to do is, if this is an unwanted column, so we can delete that column and just copy these both columns, and you will get a graph like this, the same graph that is shown in the Excel sheet for your reference. The same graph is being used in the origin. So you have to just fit this graph and copy this data and paste it in the Fityk software, and you have to go and paste it in the software. You will get the data. So likewise I am going to do and show you how to paste the data of oxygen. So this is the oxygen data. So what you will do in this oxygen data is that you will copy the oxygen data, this from the binding energy, and the another one is the counts. So you are going to copy the data. So all data is copied, and you are going to paste it in the origin software. Take another workbook, and here you are going to paste it, and as well just delete this file, and if you copy the both, just a minute, yes, you copy these both and you will get the graph. For your reference, you can check with this graph whether the graph has been same or not. You are getting the same graph. Likewise we are going to do it for carbon. So for carbon we are going to copy the whole thing. Just a minute. For carbon we will just copy the whole thing, and we have copied and pasted it in the origin software. And you will get the peaks of the carbon. So here you have got the primary peak of ytterbium oxide, you have got the primary peak of ytterbium, the peak of oxygen, and the peak of carbon. So all these data will be now transferred into the Fityk software, and I will teach you how to fit it there. Just now open the Fityk software. Here we have opened the Fityk software. Here I have saved the data. So first we are going to check about the data of carbon. This is the carbon's data. So click on the carbon. Now we are going to make sure how to save the data file in the notebook, Microsoft notebook, and then take the data file and go and paste in the Fityk and get the data. Now here we are having 4 data, that is the YB4D, the oxygen, and the carbon data. Now I am going to take the YB4D data, just a moment. I am going to take the YB4D data, and we are going to copy it and we are going to take it into the origin. So taking this data, and we are going to take the notepad, and we are going to paste the, take this as a new data, and we are going to paste the data here. This is data of YB40. And now another notepad, and we are going to take the data for oxygen. Now the same procedure, we are just going to copy for the second data, that is the oxygen data. So we are going to copy the oxygen data and going to just place it on the notepad. Likewise, this is the same for the rest two procedures, the ytterbium, the oxygen. The same goes for the carbon. Now what we are going to do is that we are going to take the ytterbium data. So we are going to save this data as YB4D data as a text data in the document. We are going to save it. So likewise, for the carbon, we are going to save the data as C1S. And here likewise we have to do it for the oxygen as well as the carbon. So we are taking the data of this one, and we are going to Fityk. Here in this Fityk, we are just going to load the file. This file from the, we have saved in the desktop, which is the ytterbium oxide folder, that is ytterbium oxide.txt. And when you open the folder on the file, you will get these data. So now what you have to do is that you have to go to data. What you have to do, you have to go to XPS. You have to remove the Shirley background. Here, after removing the Shirley background, now what we are going to do is that go to the data, and again just calculate the Shirley background. Now here we are having two options. If you want, you can add the peak here, and you can fit the peak here, and you can fit peak manually, or the easiest option is that you can fit the peak by using the auto add option. Here I'm just going to use the auto add option. Likewise, I got a peak 1 here, I got a peak 2 here, and I'm going to go to peak 3 here, and finally I'm going to have the peak 4 here. Here 1 peak, we got a 2 peak, 3, 4, and the 5th peak. Now the main game changing process comes here. After placing the peaks, you have to go and place start fitting. If you press start fitting, the peaks will be fitted alignment. So the main thing is that you have to just check this yellow line just coincides with the all the green points that is placed over here. So here just look at this. If you want to pick peak, if you want to fit the peak accurately, you can just move these red lines here and there, but the yellow line just goes away. So you have to make sure that the yellow line coincides with the green line. So if you are having doubt, you can do it manually also. Just do undo fitting, and you will get the peaks fitted correctly right about how you wanted. So this is the rough data that about how you going to fit the peaks here. The peak fitting is a little bit disturbed, so I am going to teach you how to fit it for another peak. Now we are going to take for the carbon. So we are going to take for the carbon. Now we are going to just copy the files. We are going to copy the files. Just copy and take a notepad. Just open a new notepad and just place the values and save the file as carbon1.txt. You got it? And now just save the file. Now go to the desktop, go to the ytterbium oxide folder, and you have the file saved here. Now go to Fityk, open the load file option, or you can load the file over the sessions or in the data. Go to quickly load file, place the C1 and open. You will get the data file over here. I'll just maximize and show you. So first all, what you have to do, as I told you, go to the data, go to the XPS option, remove the Shirley background. So you will get it correctly along the x-axis. Now data, take the XPS, calculate the Shirley background. Now what you have to do, you have to just add the peaks. Peak 1, peak 2. If you're feeling you want to add another peak, you can add another peak. That's no issues. Then another peak just for your reference. So we're going to start fitting here. Now the yellow line coincides manually and correctly with the peak. So you have to save this peak. Just a moment. You have to save these peaks and go and save this file and open it in the origin. Now I have just shown you a reference, and I will also fit you for the oxygen. Now we are going to fit it for the oxygen. So taking the oxygen folder, just a moment. Yeah, this is the oxygen. Just a moment. In the oxygen folder, you have the data. The data is already saved. Just a moment. You are taking the oxygen folder. You have the data over here. Just copying the data, going it to the notepad and pasting the data, and we are going to save the data. Save this data as o1.txt. You have to saving the data. You got the data. Open the Fityk website. Just load the file, and you will get this as the same procedure that I told you. Go to functions, or sorry, the data, XPS, remove Shirley background, data, XPS, calculate the Shirley background, then add the peaks 1, 2. For reference, I am just adding the third peak, and if you start fitting, you will get the perfect fitting. So if you're going to have a little bit of doubt, you can add another peak, and you can fit that peak also. You will get the exact peak fitting. So I'm just waiting you and showing you how the peak has been fitted. Now I know you will be having the biggest doubt that what you have done with the Fityk software, whether it is correct or not. For that, there is an option. You can go to the Google. There you can type as international XPS database. If you press like this, there will be monochromatic. You can just check here or check in this thing, and you can get the references whether your plotted data is correct or not. So I have saved my data over here. I am having a XPS data. Here I am going to my data. Here I have downloaded my PDF file. If you open this PDF file, here there will be the data. Yeah, look, what we did in the Fityk, it will be the same over here. Here we are just, it has the peaks of each and everything. So this is the regular ytterbium oxide peak, the peak YB4D which we are going to use now, the C1 peak and the O1 peak. Now first we fitted the YbO2. This is the YbO2 peak. This is shown here, and this is the peak of carbon C1S. So likewise the peaks which I have fitted is placed over there. So we will be showing you reference. So this is the O1 peak. I will just show you the reference of the O1 peak that is placed over here. The O1 peak is this is the O1 peak that we have just referred here. You have to refer to this one, and this is the peak that we have got here. So the data which you have got here from the Fityk, the data. Now what you have to do is that open your Fityk. This is the data that you have plotted. You have to go to sessions, and you have to, what you have to do is that you have to save this data, or you can just import this data to the origin to just get the data of your function. So when we're going here, you're just going to save this data. So you're going to do the save sessions dot fit. This is the dot fit thing. So you're going to take into this desktop, go to the ytterbium oxide folder, just going to the folder and just you're going to name it at oxygen or just O1 fit FIT. If you just do it, this is O1 fit. Your data is now this is the peak that you have fitted. Now you have to transport this peak into the origin software like that. I'm going to show you how to do that. So we are going to take the data, just a minute, data, we're going to export the points. So the export points is that the X, the Y, the active points, the model sum, the correction, and here if you press this only active points, it will select all the only active points that is present over here, and you have to press it OK. If when you press this OK, now you have to go inside. I already saved this at o1.dat, so you have to give the name o1. This is the oxygen peak, and save it as dat, and you're just going to save. So I've already saved, so I'm just going to cancel. Now go to the origin, take a new workbook, and in this new workbook you're going to import the file. So nothing wise, you can just take this. This is the file that you have saved in the desktop. Just copy, drag it and paste it over here. If you drag it and paste it over here, you will get the different types of peaks. Now you're going to save, highlight all this, and you're going to set the graph. This is the graph of the oxygen peak, the same peak that is there in the international database for the ytterbium oxide. So you have done the peak using the Fityk software. Now you're just going to align the borders and just going to give the colors. First you have to going to change the scale. We are setting it the scale from 525 and we are ending the scale at 545. So likewise you can set the scale and you can just align the borders. You can just align the borders. And you can just align the borders like this, and on the right, and if you apply, you will get the borders. And for the scale, for the y-axis, if you want, for the horizontal axis, you can start it from 0 till the last point is till 15,000. Also is very fine. Or now from y-axis 0 until 16 lakhs, you will get the same. Or else we can just put till to 1,50,000 also. If you apply, it will be aligned correctly. So here we can give different types of colors. So just have to set the background. Just a moment. So you have to make it as independent, and you have to give a separate colors for the separate things. Here you have to, the color that is there, it's given is fill the area under the curve. You can fill likewise how you want, you can fill. So this is the normal, like sideline and base. You can give sidelines only or span vertically. It's about according to you how you can give. I'm just going to give normal, and the color that I'm going to give, the transparency is up to you. You can give any other color, any color you want. So sorry, yes, you're going to give any color that you want, and the color that I'm going to give now here is if you apply, yes, you got the black color. So you can give any other color you want. For red is red, and you can just change the transparency and see it's according to you. The transparency, whatever transparency you want, you can give. This is for this line, and for this one it's red. You can give it. So I'm giving it as yellow. I'm just filling the area under the curve as normal, and I'm applying it. I will just get the yellow color. And the same way for another reading. Here, fill area under the curve, that's normal. I'm going to give pink color. I'm just applying it. You will get the pink color. And now for this one, what you have done is that transparency, and this is the transparent color that you got. And final one, fill the area under the curve. Just a moment. This is just a sideline, and I'm just using another format, and I'm showing you how it will be applied. Or for normal, you can give the same, whatever you want, you can give. So this is the block, the fitting, the reading that you will get. So this is how you can fit for. I fitted here for oxygen. The same way goes for ytterbium as well as on the carbon. So I will just show you a demo of what I have fitted before. I'll show you a demo of what I have fitted before. And this is the images that I have fitted for oxygen. This is my image of how I have fitted. This is how I have fitted. You can see this, that is the lines of 1 line, 2 lines and 3 lines that's being hidden by backside. So if you give the same colors also, you can get it. So I have fitted for both oxygen as well as carbon. So the fitting for carbon is placed over here, as well as for the total XPS I have just fitted over here. This is for ytterbium. This likewise will be fitting for ytterbium. And finally, the total image will resemble like this. This is the total image of how you can fit for various things. This is the YB203 in the origin. This is the ytterbium. This is the oxygen and the carbon. So likewise, you can fit for any other chemicals or any other things. For Raman or so for Ifteya, you can fit according to you. So hope we thought this video will be interesting for you. So please drop in your comments if you have any doubt. We will be feeling free to help you. And thank you for watching this video. Please follow and subscribe Nano Optronics Electro Lab. And thank you. Have a great day.